No, I can read it to you.
Okay, I'm ready.
It's from 3.1, number 18. It says find a cubic function y equals ax to the third plus bx squared plus cx plus d when the horizontal tangents are at points negative 2, 4 and 2, negative 2.
2, negative 2.
Yep.
Good, perfect. Excellent problem. Excellent problem, thank you. You're helping me because I meant to do a problem like this last time and I didn't get a chance to. So now here it is. Excellent. So when we're told that we're talking about horizontal tangents, what does that mean immediately?
Slope is 0.
Excellent. F prime is 0, or dy over dx in this case is 0. That's exactly what it means when we talk about a horizontal tangent. Thank you very much. So I'm going to differentiate. Obviously, first of all, let's establish how many variables we have here. How many unknowns? How many?
4.
4. Excellent. Well done.
4.
How many equations we need?
Do we need 4?
Absolutely 4 equations. Good. So let's find y prime first, or dy over dx. Say it again. Anyone? So we have 3ax squared plus 2bx plus c. And this will be 0. This will equal 0 when I plug in for x what?
X equaling negative 2 and x equaling 2.
Excellent. So negative 2 squared is 4. 4 times 3 is 12a. Negative 2 times 2 is minus 4b and plus c. Perfect. You said also plug in 2 because that's what I'm told. There is a horizontal tangent at these points. So 4 times 3 is still 12a. And then 2 times 2 will be positive 4b and plus c. So I have equation 1, I have equation 2, I need equation 3, I need equation 4. Can anyone tell us how I get 2 more equations from this, from the information given here?
So I saw on the web assign that you would subtract each equation from each other.
I need 2 more equations. How do I determine 2 more equations?
Can you like
I need 4 equations.
differentiate them again?
Say it again.
Could you differentiate them again? That could give you.
We don't have any information about the second derivative.
We could use the point slope form? No, because there's too many.
Nope.
That's
When I'm told that a point on a graph is negative 2, 4. So here's a function, or the y that we are talking about, and I'm told that this graph, or the function, passes through this point, and also passes through this point. What do I know immediately, automatically, in a blink?
the slope.
What does this point represent? What does it say to us? So negative 2 comma 4. I'll come back to this in a minute. So negative 2 comma 4 really says that when x equals negative 2, f of negative 2 must be
4.
right. So that's how I get 2 more equations. So in the original function, I plug in negative 2 and get 4. In the original function, I plug in 2 and I get negative 2. So let's plug in -2. So I have -8a. And then I have plus 4b. And then -2c and plus d. So I plug in -2, -8, and then 4, -2c, and plus d equals 4. Now I plug in 2. So I have 8a, and then plus 4b, and plus 2c, and plus d equals -2. Once I have established that I have a system of 4 by 4, I have several ways. And here's the way that I like to show. Okay, so we go to matrix. And maybe before I even put it in, let me explain the matrix. All coefficients, all terms with A are one under the other. All terms with B are one under the other. All terms with C have to be one under the other. Of course, because D is missing, so this will be a coefficient of 0 and a coefficient of 0, but the system is arranged as I wanted it to be. So I'm going to enter in the graphing calculator this matrix 12, 12, -8, 8, -4, 4, 4, 4, 1, 1, -2, 2, 0, 0, 1, 1. After I enter this, I will enter this one column matrix, which is normally denoted by lowercase b. In the calculator will be an uppercase b, which is 0, 0, 4, -2. And in order to determine what we are interested in, we are going to perform this calculation with the graphing calculator. Yes, we can do it by hand, by elimination. We can. But this is a much better, easier way. In case you remember it, that's fine. If you don't, you'll learn it now. So under second and matrix, go to names. So we want to edit. Scroll directly to edit. I don't need that matrix that I have there. I'm going to overwrite it. My matrix is a 4-row, 4-column matrix, so 4 by 4. And I'm going to enter everything by rows. 12, -4, 1, 0, etc. So 12, oops, no, not there. Enter. So 12, -4, 1, 0, 12, 4, 1, 0, -8, 4, -2, 1, and 8, 4, 2, 1. Second and quit. Go back with second and matrix. Go back to edit. Now I want to edit matrix B. And this is a 4 by 1. And I enter 0, 0, 4, and -2. This method is called the inverse matrix. Method. It doesn't always work. If the system has no solutions, you will not be able to apply it. But I'm hoping that the system has solutions, because otherwise they will not ask us to do this. So go out of there and go back to second and matrix, call matrix A, put the power -1 right here, power -1 on it, and multiply, and go back to second and matrix and select matrix, not A. We're selecting too fast, dear calculator. B. That's it. So I have A inverse. This is called not A raised to -1. Of course, it's the same notation for the function inverse. So that's matrix inverse. So it's A inverse.
Can you do that last step? I'm sorry.
Yes. Yes, let's do it again. So second and matrix, and call the matrix. Just press enter. Put the multiplication symbol. Go to second and matrix again and call matrix B. Go to matrix B and press enter. And when you click enter, these are your coefficients. So y equals 0.1875, and we can change that to do a fraction in a minute. So x to the third, b is 0, goodbye, minus 2.25x and plus 1. If you have any difficulties changing these into fractions, you go to math. So first of all, I'm going to put 0.1875, go to math, click on fraction, it will give you the fraction, 3/16. If you want 2.25, go to math, click on fraction, it will give you the fraction 9/4. So this is nicer, as 3/16 x cubed, and minus 9/4x and plus 1. This is guaranteed to have horizontal tangents at the given points. So this is a much easier way than using elimination on a 4x4 system, assuming there is a solution. Otherwise, this method fails. Because the determinant will be 0, the determinant of the matrix, and the matrix will not be invertible. This will not exist. But lucky us, it exists, so we got the solution in a blink, sort of. It was still a lot of work to put it in the calculator. Very good question. Thank you so much for bringing this to class. Is there anything else?
I have another one.
Yes.
It's on 3.2, number 7, and it states differentiate, assume c is a constant, z equals y to the 3 halves times y plus c e to the y.
I have to reach into my recycle bin because we just did it a few minutes ago. Here it is. I distributed, and you get x to, or y to 7 halves plus c, y to 3 halves times e to the x, and you apply, you differentiate the power like this, and then the product.
Okay.
Is that good enough? Should I add this in the lecture and just scan it for you and post it?
No, it's fine. I have one more and then I'm done.
Okay, but is this clear?
But this one, you have to, yeah.
All steps clear?
Yes.
Okay.
Yep.
Okay, so then what are we doing next?
This is my last question. It's on number 16 of 3.2. It has a graph, so you might have to pull up your WebAssign.
Okay, you said in 3.2, 3.2, 3.3. Okay, 3.2. Okay, I clicked on it. And you said number 16. Let's take a look. 14, 15, 16. Yeah, I'm reaching again in my recycle bin. It was done in class.
Oh, okay.
It's in the notes on page 13. It's just that. So if you just watch that little 5-minute video. So all you have to do is just identify f prime, g, f, and g prime from the graph. So when you are asked to find f prime, you will determine. That's why I said always redo the notes first before you start anything. You're going to feel so much better. So when you're asked to find f prime, then you're looking for the slope, and you create a right triangle. So this is 4 divided by 2 for f prime, and and if it's like this, it's negative. And then the other ones are just the function values at that point.
Okay.
Is that better?
Yeah.
Okay. Very good. Next question, is there anything else that you worked on? Anything else that you would like to work on? Anything else? Anything else?